Hi everyone, afraid I got a bit of a cold today, and so I haven't done any recording during the weekend, so I'm afraid you might hear me sneeze a few times here. So since last time when we recorded part 8, I believe, or part 7, can't quite remember, we were fighting against issues. In fact, let's just have a quick look here where we were. So about 4 days ago, we were trying to split the generated tests from the non-generated tests, because what happened was, and we probably should start clocking. Interestingly enough, we don't seem to have a direct backlog. Just open up our agile area here. Okay, it's a bit better. This is agile. Right, so I think it's fair to say we spent probably the last 15-20 minutes maybe faffing around with the audio, trying to get the sound right. We never seem to get the same sound for every episode we record. We also spent a fair amount of time trying to sort out the 3Max issues, but thanks very much to Alexander Miller. So if I have a quick look at 3Max, hopefully we should see here, yeah. So we've bumped into a number of issues with 3Max, and thanks very much to Alexander Miller, who has been extremely helpful trying to fix the issues with the latest update from 3Max. Pretty much replied instantly to all the comments we made here, and now it seems like 3Max is up and running again. But what we're actually working on is splitting the generated tests and the manual tests. We've made some progress since last we spoke. I'm going to close some of these things here because we don't really need them anymore. May do a lot of sneezing and coughing as well while I record. So I'll just close everything from the reference model. So what we've done is we went to C++ generation model, and we looked at the tests facet, which is this guy here. We changed a few things. So for example, now the test directory is generated tests instead of just tests, and there were some other associated changes we needed to make, like for example, make sure CMake was picking up the right directories and so on. And we also renamed, and you see this in compilation if I jump over to 5, we renamed the tests binary to be called .generated tests instead of just .tests. That's just so that if we have tests and generated manual tests, I guess, and generated tests, you can see the difference between the two. So we've done all of that. We pushed that onto the reference model, and that seems to work okay. The reference model, I mean, still not perfect, the reference model builds, but kind of getting there. Linux seems to be working okay. As you've seen here, all the tests have moved. That's because the test suite has changed names. So if you look at one of these new tests, so we have 141 passing, so quite a few missing tests. Presumably the missing tests are all, there we go, so these are the new tests, and I think the key thing is the .generated tests instead of the .tests, so that's what you expect. Okay, that's all looks very good. So okay, so the next task we need to do then is to say, okay, can we in the main Dogen binary, can we now generate two different sets of tests, generated tests and tests. So we've already generated source codes for tests. Sadly, we are not generating the MakeFiles for tests. Probably could get away with generating those, though of course we don't need them ultimately once we disable it. What's the easiest thing to do here? Could say, well, let's just take the easy way out, as we often do. Let's just say to the profile that we need test.cmakelist enabled true. That will generate the make files that we need in order to build the tests. So jump over to actually I need to start the build from here so that project app picks it up, and then if I just say generate everything, and it just generated everything, and now we should see if I jump over to integration, yeah, we just got a whole load of make files that got generated. And that looks quite healthy. So what I'll do is, we'll just need to make sure that this doesn't cause any problems. Interestingly, okay, just pick up generated tests, because relational tests, because apparently we are using the makefile for that. But everything else didn't cause any problems. So what we'll do is we just, for a laugh, we'll just say CMake generate make files for generated tests. Update profile to generate CMake and regenerate CMake files, something like this. Okay, cool. So that's good. Now that we've done that, probably the next thing to do is to try to start hooking these tests in. I mean, we don't have to push this, but so sadly these files are being generated manually, so there's no other way other than here say generated tests, and then just start building things. Right, as you can see, it's now picking up the generated tests. Interesting. Let's find -L Dogen. Okay, this is where we're going to start to find some mismatches between generated code and handcrafted code. Sadly, this might be more of a problem than we bargained for, because as I explained in the past, we haven't quite updated the makefiles to fit the latest and greatest format, which is what we have at the moment. And as you can see here, we have now a target name with a .lib. This is the new way of doing things. We don't seem to have that for the generated test just yet. So now we're a bit stuck, because the options we have is we can either manually generate all of the CMake files for the generated tests, which will only allow us to go to the next step anyway, because sooner or later we're going to have to remove these generated tests altogether and get them to generate automatically. Because remember, this is the ultimate goal. The ultimate goal was that we wanted to have a nightly build where we just enable all facets, including generated tests, and we run all facets, and then in that build we check that the generated tests work. So we're not really going to have much of an option here. We need to make sure that the make files work with the generated tests. And now the problem with that is we have no option but to update all make files, because CMake files, because if we start modifying the make files to match this .lib purely for Dogen, then the reference model is gonna barf. So yet again, find ourselves a little bit sidetracked here. Didn't really want to take on this task just yet. Let's look at something like assets. Yeah, you see quite clearly here we have the .libs. And then on top of that, these make files are actually not generatable altogether, because we have some features here that Dogen doesn't support yet. Which is not a big problem, because of course we could leave these as manually generated for now, update the generated make files to match the new style, regenerate the reference implementation, and then pick up the change only in the generated tests. Generated tests then should work, and they should basically be interface compatible, if you could call it that, with what we're generating for CMakeFiles. And that sounds about right. I mean, it's a lot more work than I expected at this point in time, but we haven't got much of an option really. So what we'll do is, for now, we just remove that for a second. So let's say we have a quick look at the stitch templates for CMakeLists. So now this is probably a test stitch template. What we want is the source one, this guy here. Okay, so let's look at how different these things look. It's not dramatically different. Of course, you have to make sure you don't break ODB in the middle of this confusion. That might just be doable. Let's just give it a go and see how far we get. So, first thing we need is something like the product name, presumably. This is all ODB stuff. We must have something that is actually oh yeah, install target. Target 98, product name, add library. We have the files and we have a model name. Right, so one thing we can do here, just to make our life easier, is you can look at the reference implementation. And in here we can see, if we just take a simple model, like say, our thing is actually not too complicated. If we have a look at this CMake file, so you can see here, of course it does have ODB, so it might not be the easiest thing to look at. Say we take something like the boost model, for example. Right, what we see here is, right, here we go. So, you see that this guy here has got a model name, which is something like underscore separated junction of both the product name and the current model name. So that's what we mean when we say model name here. We chase that model name up. Right, so here we go, we made it identifiable of the name. That's rather different from what we got right now, because what we've done is we're using dots and everything. We're basically saying we want the target names to actually have dots in them. And then the target name just has .lib, but the library name doesn't. So what we really want is the original product name dot model name. So we have a product name, and what we call it model name is actually more than a model name. And C is a CMakeLists object. So this is using the old meta model in C++. So go to Fabric, CMakeLists. So in here we should see, if we look, something such as, oh, we just have a name actually. So CMakeLists, I was expecting to see CMakeLists.name here somewhere. So include directory path, source directory path, header file extension, implementation file extension, maybe targets, test directory name. No reference whatsoever of a name. However, in here, C is casted into a Fabric CMakeLists, and then we say C.name. That's a bit puzzling. There's no inheritance. Maybe there is some inheritance. Oh yeah, okay, right, so you are some hackery here. So we are actually of type element in the meta model, so it's just using the meta model name. Alright, cool. So probably want some other function here that computes the name by taking, in fact we probably already have some kind of function like that, right? We must already be doing something like something dot something else, right? Perhaps not in the make file, but let's think about a place where this would be used. Doing a join between the different components of the name. Well, perhaps what we can do is we can just have a quick look at the assistant and see what this. So in C++, this guy here would do. So the assistant lives here in the formatter namespace and contains a whole bundle of functions that do clever things for us. So for example, this function we're calling over there, get identifiable model name, all it does is uses with join to join model modules with an underscore. And presumably we then join that to product name. So a.getIdentifiable model name, that only seems to take into account the model modules. Product name only seems to take into account, presumably. Interesting enough, it takes into account external modules. This seems also like a bit of a hack product name. See, this is one of the reasons why we cleaned up MakeFiles, because the logic around all of this was very, very strange. Really, what you want to do is you want to say, for every element that you've got, maybe just the model modules and the internal modules, and actually you don't even need internal modules presumably, so it's only the model modules, and you just want to join them with a dot, right? So that's, for example, if let's just have a look at a model module. The model modules are basically a way to name the model in a way that we know what is actually just a component of the model name. So for example, Dogen, .generation.cpp is the model modules. So we now know that whilst there are three namespaces, Dogen, generation and cpp, we know that these three namespaces are actually all components of the model name. Whereas, for example, formatables is an internal namespace. So for now, what we're going to do is we're going to say, just like we said, get identifiable name, we're going to have something like so obtains the model name as a string, so gets dots separated. Now of course strings separated by dots. So of course this is not particularly brilliant. I mean, there's a lot of things at the moment that we're doing just to get things going to the next bit, and they need to be revisited. But sadly, we just don't have the time to really look in depth into the best way to model these concepts, because we have much bigger fish to fry. And we just don't have the time really to really look into great detail as to what is the right way of doing things here. And for now we just need something quick that allows us to progress to the next batch of problems. Otherwise we'll get stuck forever. So what we'll do then is we'll basically say, okay, we can now obtain a model name via this new method. sorry, I picked up the C# instead of the C++ one. Now, of course, we just have to be very careful when we say we now have two model names, because it could be used for many things. Luckily, it isn't. So I'll just override this and say, okay, give me a dot separated model name. And now, now we can just resume our CMake list as it was a second ago, which is one of these guys here, not quite that chap, but pretty much any of these. So we start by asking for a name, and the name is the model name. Then we say, okay, give me a lib target name, which is with the dot lib. So we must have started doing this early on, just never quite finished. So indeed, so you can clearly see we're missing the binary name here. So so we set the name to be the model name, then we set the lib binary name to be the lib binary name, and then the target name as the dot lib. And then instead of all of this, we must make sure we're actually not... yes, okay, we have a problem here. So we started modifying the wrong stitch template, and we will have to modify that template in a second, but not just yet. So let's just ignore all those changes there for a second. Right, so let's start again. So where we're saying, and here is what I wanted to make sure we don't have lots of mentions of model name. Okay, it's just all in places where we know what it does. So we can fairly confidently then say that the model name now is a dot separated model name, and then we can say, okay, can we please have these things here to mean model name, lib, okay, that looks good. Files, to be fair, I think we probably want to do exactly the same thing as we did before. So just obtain a list of files, whatever the implementation extension is. We captured the ODB files, that's not a problem. Now then, add library, right. So the first thing is, we said that the lib files are the files. I think clearly we probably do the ODB magic here as well, but that's fine. But now notice that we just want these non-macro based entries here. And then the output name also. See, the output name now does not become so complicated because we need all these things here. Product name. I'm going to have to experiment with this. And then for the targets, of course you know that we're not generating executables, so this is all a little bit hard-coded just for now. And then finally we look into the ODB targets. Now for the ODB targets, the ODB targets, we are adding a custom target, which is the main target name. Then ODB, I think actually by sheer luck we don't have to worry about this, because the ODB targets are more or less independent of the other targets. So I think by sheer luck we're probably okay with these guys. And then if I try to generate Dogen generation.cpp.dia, here so you can see, and then try to build this guy. So what's a lot of files changing? That's a bit surprising. In fact, it's rather surprising. I'm not sure why we changed every single file in generational CPP. See what Git says. We have to, yes, we touched the assistant. Okay, that's correct. I mean, we always have these moments where we think that something has gone very wrong, but normally Make does not make mistakes. Right, now if I just do something like generate C++ ref impl dot northwind diam. This is a pretty if I could spell northwind.diam. Right, this is a pretty simple model, but it also has ODB targets. So right, so as you can see, the CMakeFile is now changed to this new other format. Let's just have a quick look at what the file looks like. So as you can see, now we have the dot separated version as we did, the dot libs as we wanted. Well, I'm just feeling a bit brave and see what happens if I try to compile. I suspect the test will fail, but it's compiling the ODB files as well, so that seems to have gone well. Okay. Then we have a slight problem with linking. Right, okay. So I suspect the problem is with the tests, right? So this is what we really wanted. And that's exactly why the tests were failing a second ago. So if I now go to tests, now then I actually attempt to change my excuse me, yeah, so now as you can imagine, we are actually in the tests. So in the test, what we want to do is to say, right, so give me my dot separated name, and now I do want to see my lib, and in fact that might even just be enough. So if I just generate C++, compile the code generator, okay, and now this point in time we are good to, okay, I don't really like to have too many compilation entries here because start hopping between projects and then it's kind of hard to see where we are. So are we in Git? We are in Git. Okay, so now generated test got pre-generated, and now as you can see we have the lib here. So if we take away all that nonsense and attempt to compile, now what's happening is that the tests are also pointing to lib, and a compilation actually works successfully. So good measure, we will just regenerate every single model for the impl project. You see a whole lot of changes in CMake, and then we will just try to build with all these new CMake files. Clearly this is going to result in a major rebuild. Not much you can do really. Let's see how you're doing for time. Even I'm not feeling particularly brilliant, I'm not going to make too much of a long session here. So we start at 21:23, probably last an hour or so. So the objective really here today, I mean I guess our objectives are becoming narrower and narrower, but our objective today is to see if we can move over to these generated tests, so that in our builds we are running the generated tests separately from running the handcrafted tests. That'll be a good target for an hour or so session. First I thought it was actually quite an easy target to achieve, but of course as before I realized we needed to make some core changes to the MakeFiles. It's actually going well enough. And we just need to make sure that we can run the usual targets. close to it now. Takes a bit longer when it starts getting to the linking phase. The thing we need to do as well is we need to add the option to the to the reference simple, not to build with ODB, because that's what's causing all these problems here. So perhaps once this is green, and it's very nicely green, we should just also do that. So what we'll do is generate models with latest Dogen, pick up new CMakeLists format for both SRC and generated tests. Okay, so while we're here, we should just do a very quick hack, and hopefully it'll be quick. So what we did before is we added an option, did we? With relational support. So so if I just pop over to 7, again, because we are manually generating a lot of this stuff, it's quite sad that we need to do this in 2 different places. Really, in an ideal world, we just regenerate, Dogen will pick up all these changes, but sadly this is not the world we live in. But so we can say something like all of this stuff becomes inlined, or indented, should I say. And open SSL. I'm not sure why we're disabling ODB on the basis of OpenSSL not being found, but let's not ask too many questions, otherwise this will be a never-ending story. Right, there we go. So now then, you can see here we isolated everything to do with ODB, and what we need to do is in projects we just need to figure out maybe some very simple check to see if that option is enabled or not. And Northwind, which is already nicely isolated here. So I'm actually just going to do this the quickest possible way. I wonder if there's an AND. Right, how do we do an AND in CMake? So CMake relational operator AND. If AND, okay, so there is an AND, so let's just do something like AND. Save us some trouble here. Right, so now then, now we have this with relational support. Hopefully this will mean we'll only build when we ask for it. And if you remember, we needed to change 2 files for this. The Linux build. So let's have a quick look at what the other project had on the Linux build. There we are. This is set to on. So of course they won't find it because it doesn't exist, but oh, actually we didn't open the Linux build file. What we really wanted was this guy here. And so what you should see here is a number of options. Let's make sure we put somewhere similar. So with benchmarks, latex. Right, let's just put it here, right? And then we also want the we are in diode mode, so with the ctest file, and we need to see what the Dogen ctest file looked like. Again, we're in direct mode. So I'll just have a quick look at with with relational support. Okay, so around the area we're looking for memcheck. Just need to check. Right, see what we're doing here now is to say, well, if you're in certain operating systems, Unix, not Apple, that's another way of saying Linux, set it to on. Okay, so now we'll just make sure that that does not cause any problems, it doesn't actually cause any changes. So if we just jump over to say 8, now we should see a whole load of changes related to this work. So we could just say something like CMake, CTest, make relational, make ODB optional. Right, now, so what we'll do is, because everything is green at the moment and because we're testing this thing, what we'll do is we'll merge that and push. The idea here is that we might as well, while we wait, might as well get the build going, because these builds take a while, even just to see if the error is coming through or not. And so what I'll do is I will cancel any builds we've got outstanding at present, and just leave this build running. So in a second we should see if this worked or not. Now going back to what we're trying to do, what we are trying to do is now, so we've updated, actually this was a very brave thing to do, because I think if you were to actually run all tests from Dogen, it probably will fail, because we may have not have generated, let me just show you what I'm seeing. As expected, we have some failures here. Actually, the failures are not too bad. The failures seem to be mainly to do with the Dogen models. Whenever we were generating things for the Dogen model, so that's actually quite a good thing. So it means we didn't break the build with that change. However, we do need to generate all models, because we're going to find that all tests have changed now. All the stuff to do with tests, right? So let's just try to see if a build would not break anything. So with this, we have now picked up the change to any tests that were generated that we'd made in the past. And now, hopefully, the CMakeFiles that we have in Dogen are interface compatible with the CMakeFiles that Dogen is generating. It's a bit silly that they weren't before. I mean, it's just purely laziness, as you can imagine. We have hundreds of little tasks like these ones that need to be done, and the question is, when do we do it? And I tend to do them only when I really have to. Still not quite there yet. Okay, right. So these are two special. Okay, so the build is actually worked at all. These are two extra models that we've got that are slightly special. So I need to cough 1 second. So these are two extra models that we have that are a little bit special, and these are the out of sync and the delete extra. Basically, these models test some features of the code generator, such as deleting extra files and so forth. And because of that, if the state is out of sync, that the code generator does the right thing. So because of that, it requires a little bit of hand-holding to get these models generated. So what we need to do for these models is we need to delete, to get the models in the state where the code that they generate is the code that exists in Dogen at present. I think the models do have the comment telling you what you're supposed to do in order to generate them without breakage. So in this particular case, the delete extra files, we just need to disable delete extra files. And the next thing we need to do is we need to enable, sorry if I go to models. So we need to make sure that these models are enabled. as they are now, and now we can generate all models in the ref import. Now I just have to be very careful when generating these two models, because they are it's very easy to get these models broken. So that is a change that we wanted. That also looks good. Now we don't want to pick up the changes in the models themselves, because we know it's just a hackery. And we also don't want to pick up the change that enables the generation of these models, because we know that was just required to generate them in the first place. And then all we want to do is to make sure we can build. As you can see, it's seems to be going. And then we just generate all run all tests. Okay, so that looks good. So we return to Git, and we basically generate delete x models that cracks the out of sync. If I could type, it would really help. Pick up new CMakeFiles. Pick up updates to the CMakeFiles structure. Something like this. Now then, if we were to try again to run our tests, because these models are now up to date, hopefully Dogen is going to be slightly happier that code that's generated, okay, matches the models is what you want. It's good. So at this point in time we could say that the generated models look good. So I think we could probably commit all of these with a similar comment to what we had before. For generated tests. Okay. Now then, so now if we attempt to do the test that we did a second ago, and that test was very simply to say, on my main CMake file, can I have both generated tests and non-generated tests? And if I just compile this, okay, we go to the next error now. Don't seem to... okay, so we have another problem here. Okay, so we, in our profile for Dogen itself, we normally don't need to generate the main for unit tests, because of course we have manually generated mains. However, now that we are separating, we need to. So if I just set that to true, drink a bit of water. Okay. So again, if we go back to Git, I assume we're going to see a lot of mains. Now, if all goes according to plan, now of course the reason why we haven't seen any problems yet is because we're not compiling these new generated tests, but hopefully, exactly, so this now works perfectly for the one thing we're testing. So what I'll do is, I'm not going to take that in, I will take both this and all the mains. Main, generate main for all generated tests. Sorry, this cold is getting to me. Okay, so now that we've done that, what we're going to do is something rather interesting. We're going to now say, for all the projects, we're going to do exactly what we did just here. We're going to say, can you please, for every single project, and of course this is where, as an Emacs user, you start to think, do I really need to do this manually? Because I could easily do a grep here and use the read-only, sorry, the read-write grep. sometimes actually you end up feeling a bit lazy because just the time it takes you to think about how to do that versus doing some brain numbing copy and paste. Sometimes it's actually easier to just copy and paste. Though of course it's always a sign that you should be generating this code. But there you are. Let me just go through these guys one at a time. It's actually quite a relaxing thing to do in some ways because it doesn't require any thinking. I think we lost a little bit of that now in these days in programming because everything is so automated. I mean, I'm working on code generators, so clearly I'm one of those people that are responsible for taking these activities, these tasks away from programming. But when I started programming, copying and pasting and manual labor was quite common. Now it's not so common anymore. Okay, so we're reaching the end now. We'll just do utility. So at this point in time, our objective is to say that we are running both the generated tests and the tests. Now of course you're going to say, but we are also running tests that are generated tests within the manual tests. And that's actually correct, we just haven't deleted them yet. But we do that as a second step. So first we just want to see what kind of problems we get with this. And we've already got a few. Okay, so this is a classic kind of problem where well, to be honest, I was just going to say this is where the generated MakeFiles have got some limitations because we're not picking up references. But in reality, sorry, let me just look at the project again. So CLI, in reality, actually, I think this is a bug in CLI. So I think what's happening here is CLI was lazy and didn't declare a reference, and there you are. Didn't declare a reference to the utility project. So if it's using logging, it should be referencing utility. So really, because of course, as you probably know, references are transitive in CMake. Terrible cough, I'm afraid. Okay, so what is the problem now? So model processing configuration, model processing configuration. Let's have a quick look and try to understand where this is coming from. This would be one of these projects. It's coming from Dogen. Okay, so exactly the same problem, just different project. And yeah, this is where everything will come out of the woodwork. Of course, remember that we've just changed how the MakeFiles work, so now using the new way of doing things. I still have a mute so that when I cough I don't have to be taking the headphones off. I haven't quite figured out how to do that with OBS, which is actually quite a nifty piece of software. We always use OBS for all the recordings. Okay, so that's looking quite good. So while we wait for these 226 translation units to compile, we'll just have a quick look to see how much breakage changed it to the Okay, nothing has gone through just yet. First Linux ones are coming through. Perhaps what we can do is we can hop over to the project itself and then jump to Windows. Yeah, as you can see here, it's kind of doing something at present. And so there's no point of interfering, let's just wait. Hopefully we'll get some slightly greener builds. Okay, so, okay, still good. Right, that looks quite good. Now, see what Git says. Right, so we've included all of the generated tests. So now I think we could just do something like CMake include generated tests into projects. Right. One thing we did forget to do, which was quite an important thing to do, is if we do a rat, we get an error. Interesting enough. Error comes from JSON. Do you know what? I think the problem with JSON is this is where you find your problems. I reckon that there is no types to test in JSON. Indeed. And because of that, we probably are generating. This is where you end up having to do silly things like injecting fake tests or something. The right solution, of course, is to just not run the tests, but we need a little bit of cleverness for that to figure out that there's nothing to test. So I'm not even sure what the right thing is here, because we don't. I mean, it would take us quite a long time to do such a deep change to try to understand that there are nothing to test. And we don't really want to get involved in another wild goose chase while we're trying to sort 4 or 5 other wild goose chases. Do you know what? I'm going to do yet another quick hack, and I'm just going to add a type here, which I shall call fake test. And I think I don't even need anything else. That's probably sufficient. And I'm just going to generate. And now hopefully what we'll see is that we know, we now see that there is a test there for that fake type, and hopefully the test will just pass. Interesting. Okay, cool, that's good, that's good, that's good, that's exactly what you expect. I mustn't forget to sync up the JSON model. So convert Dogen dot injection dot JSON dot type, and then we need to indent. It's a little bit curious when you start working on a code generator that generates itself, where we have all these sort of self-references where you are working on something that's actually referencing itself. Such as, for example, generating the model that generates the model, and so on. And this is just always a little bit confusing in the beginning. Now I'm actually quite used to it, but it took me quite a while to get used to this. Okay, we still have a few problems. Still in JSON, interestingly enough. I wonder if the problem is that we are comparing. No, we're comparing integration. So clearly you can see here what's happening is that we are finding that every single main that we generate. Okay, it's probably another problem with JSON again. we need to ensure that the profiles in JSON are synced up. So if I just do a convert, I think also this implies that I haven't been very diligent in running the unit tests every time I do a commit. Seems to me that the build was actually borked a few commits ago, but there you are. Okay, good. Now then, so if we just add all of these, generate, so I can say this is injection.json, generate fake tests to get tests to work, generated tests work, I guess. And we also update JSON models, or sync JSON models with models, missing profile changes related to main file tests. Okay, so that's that. We probably also should go to the backlog and say we found another bug. So detect generation of test generated tests fail when model has nothing to test, something like this. So in cases where the model where we are generating tests for a model which has nothing to test from a Dogen generated code perspective, the tests will fail with an error. This is because boost test expects to have at least one test registered. In the past, we have solved these by adding fake tests, which kept the test suite green until we added real tests. However, for generated code, we need to somehow determine when the fake tests should be injected. This may seem simple, but it's actually not a simple thing to do, because it's almost like you need to go through the whole test template and figure out whether any test was emitted in the template. So this is not a trivial thing to do, because we need to ensure that the test template did not emit a single test for a given entity, and then look at all entities and see if there is at least one test or not. Okay, this is probably enough for now. I mean, normally when we raise the first story, we don't really need for this to be the most perfect story in the world. It just needs to have enough detail that when we go back to this, it makes some vague sense. Now then, so now we go to the next stage of our operation, which is to say we now need to remove all of the generated tests that are in the handcrafted tests section of testing for Dogen itself, right? So for each of these, we're probably going to find that there are loads of tests here. So for example, you see this fake test here. This is what we were talking about a second ago. Whenever there's nothing to test, we inject these fake tests. and the job of the fake tests is to ensure that the code compiles. And just for good measure, what I'll do is I'm going to add this to our story, so that if we do need, so example fake tests, if we ever need to src just put this here, so if you do need to go back to it, at least you know what we're talking about. Right, so what we now want to do then, we just have to make sure we're not in master. What we now need to do is we need to go through all of these tests and delete anything which is not a real test. In other words, not a manual test. This is actually not as easy as it might seem, because for each model we need to sort of look at the types, I guess. So for example, configuration tests comes from there. It's not going to be particularly easy at all. Database engine, that's the enumeration presumably. Maybe the best thing to do is to say, if a file with exactly the same name exists on the generated tests, then it's a sign that it's not a real test. And that would then allow us to much quickly, yeah, exactly. So from here we can easily now say configuration test, database engine test, diffing configuration test. Now we leave fake tests for now. Model processing configuration test, reporting, tracing backend, tracing configuration, tracing format, and tracing level. So this is pretty much everything really. And now we're just left with the fake tests. This is actually quite an easy way to do this. So again, let's just go to the next model. Use the archetypes, go to tests. And in here, what do we have? Location group tests, location repository parts tests, repository tests, location tests. Now, part of me says we should probably just delete empty test suites. But the other part of me says, well, we've already done all the hard work creating the empty test suite, shall we just not just add a fake test here? Takes 5 seconds and then because the fake test doesn't actually do one thing is important. The fake test is it must reference the right test suite. Right, so archetypes is done. Assets is going to be humongous, presumably. So, well, we don't. In the namespaces, we're almost 100% certain that there's nothing. Okay. This is a bit of a mistake. We're meant to be in generated test, but okay. Now we know for sure on the namespace there's almost nothing there. And probably everything else is a real test, so this is good. Let's go to CLI. And CLI we have pretty much everything, but not quite everything. Okay, that's good. It's somewhat obvious that we should have done this in the beginning really, but with a lot of things in Dogen we tend to find things in hindsight. So attribute test, boolean test, child node test, color test, composite tests, connection tests, diagram test, enumeration tests, font tests, integer tests, layer tests. shouldn't be worse than usual in this video. Object tests, point tests, tests, finger tests, and string tests. Sneezing again. Okay. Yet again, I think I'm going to be tempted to just copy across my old friends. I mean, I shouldn't really be copying this fake test really, but anyone that codes will tell you that you should never do temporary things that are there just because one day you might need it. Just not a good idea really. In fact, to be honest, I am going to remove this. I was just being a bit lazy really, but I think I'm just going to remove this. So for any cases where we haven't actually got any tests for now, let's just remove the test directory. And that then implies we need to remove this as well. We'll just do that for now. We'll do it like now actually. Just a slight laziness. The problem with laziness is that it just generates, in fact, you try to be lazy but end up creating more work for yourself. Now what we need to do is we need to keep track of what we're deleting. And also we probably want to make sure that things are compiling as we go along. So to do that is probably to say, where are we now? Archetypes, assets. Assets look good. CLI look good too. Dia didn't look so good. Right, so we'll just stop our laziness. So up to now, all the way up to Dia, we don't have any tests that are not supposed to be there. So we just compile and run. Don't expect any big differences here. Right, so engine. So just look at generated tests. Well, first thing is get rid of helpers. Then we have pretty much all of these are actually good tests. So that's good. Engine looks very healthy. Extraction. Extraction I don't think has any tests. So no helpers, no meta model. Oh, it does. There's 3 tests here. Generation. Don't think generation has any tests. Well, first to get rid of all the namespaces, because we definitely have online tests on namespaces. Oh, we do have some tests. Pretty much all of these, funnily enough. Very good. That was generation. Well, I was going to say generation, that's it, we definitely has many tests, but I've said this a few times already. And this time I was right. So what we need to do for this guy is to get rid of the test directory, inclusion of the test directory, and then we'll do the same thing for C#, because I'm pretty sure it's exactly the same. So nothing here. Delete the test directory and do not include the test directory. Now at this point probably want to go to Git, include all this stuff, go to compilation, compile everything, run everything, and it all looks still quite good. Okay. Now then, injection. What do we have in injection? Well, clearly not the namespace. And if the namespace is not there, then don't think there's anything else. So No test for injection. For some reason I do seems to switch itself off. I think I have a problem with I do in Helm. I never quite learned how to use Helm properly. So injection.die, I think we have injection.die tests. So die object type tests, processed attribute tests, processed comment tests, processed objects tests. These are actual generated tests and the rest is not, so that looks good. Now this chap is definitely going to be one. Oh, injection.json. There's yes, there is no. Okay, this is absolutely correct. So injection.json doesn't have any generated tests. That's why we had that problem before. Now what we did is we created that fake type. So now we do. So that one looks very good. Relational. I think we don't have any tests for relation. So we just delete the test directory. That's good. And templating. I think we have plenty of tests and templating. So not all of these are tests, so stitching well are not. And then pretty much all of these up. Okay, that looks good. Tracing. Tracing. Yeah, I think we don't have any tests in tracing because what I meant to do is to say, yeah, metrics tests are not real tests. Well, they're generated tests. And away we go. Okay, so where are we? That was tracing, utility. Suspect we have quite a few utility tests. Not in the namespaces. Pretty much everything else is left is a utility test. Variability. But definitely not the namespace. And that's probably a good test. Right, so at this point in time we've removed all of the tests that were under manual. Tests that were under the manual facet, but were actually automatically generated. Now, the reason why I stopped talking there for a second is because I just remembered that I have some notes on how to address manual tests from a Dogen perspective. So if I just take assets as an example, if I look at my manual tests, you see we have all these tests here. And now, the way we tell Dogen to ignore these tests is we've got this very blunt regex based approach where we just say, okay, anything on the tests, just ignore it. Now that kind of worked, but it's not really in the spirit of Dogen really. What you really want is to define an entity in this model to represent the tests, to give it the right meta type, and to project it across the right facets. So really, what we really want now is we want to have two different facets. We want manual tests and we want generated tests. And we want the manual tests facet to write to a folder called tests. So okay, I see exactly how this should work. Let's just go back to Agile. Now we have a story for this already. So if I just look for perhaps something like tests. Add logging support, generated tests, fix Northwind tests, testing validation. Consider adding tests for pipeline components. Add tests. I don't see it here, but presumably we probably moved it across. Fix issue with tests. Oh, actually, do you know what? I think we may have deprecated it. Right, so okay, I'm going to undeprecate this story because actually it's not entirely wrong. it's just not quite. So let's just put here previous understanding. So really what we're trying to say is, at present we have a tests facet that contains only the generated tests. We also have created folders for manual tests under a directory under the tests directory, and writes to the generated tests directory. However, the problem is that we still have no way to tell Dogen about the manual tests. This means we must use a regex to ignore contents of the folder. A better approach is create two distinct test assets. So we need to have a manual tests, generated tests, create a profile that enables manual tests. When enabled, we simply create a skeleton boost test file. We must set it to override so that we update the contents of the file manually with real tests. Okay, so now this is a much better way of doing it, right? Because now what we're saying is, if we annotate something with tests, and to be honest, we probably want a manual test stereotype really. The manual test stereotype will allow us to annotate some types, and then we can let Dogen know that manual tests exist. And once we've done that, then we don't have to do that regex anymore. And we also have the skeletons, which is a plus. Okay, we've been doing this for an hour, so it's getting a bit late. Righty, so I think we could probably commit. Yes, please. Now at this point in time, this commit is going to be remove generated tests from manual tests folder. And finally, we just set some agile backlog grooming. Right, so this sounded really complicated. So let's just recap what we've done and where we are. So what we've done today is we continued the work to split generated tests and manual tests. We pretty much got all the generated tests onto the generated tests folder. We got those tests to compile. Turns out that there was a mismatch between the CMakeFiles of the generated tests and the CMakeFiles we were manually generating. So we had a massive parenthesis in which we had to go back and update all the makefiles to match this interface. And that was done, and then we hooked in all the generated tests and got all those to pass. And then we just manually removed all of the generated tests that were living on the manual test folders. So at this point in time, we have isolated the generated tests. So we're not going to finish today the task, but really the next steps will be to create an option. Well, actually, not quite to create an option. We need to look into the nightly build, because if you remember, we're only going to generate the generated tests in the nightly build. So we've already created the overrides to generate all of the facets. So we just need to choose to do generate all using the overrides, and then just build and run all tests. then what we need to do is we need to have something in the CMake file that says run only generated tests, not the manual tests. And that should take us there. So for now, what I'll do is I'll just merge and push. I'll also push to our bit buckets. And for good measure, we will have a quick look at our so it doesn't look like we've improved things that much. For any of the builds, which is peculiar. I would have thought that at least I was expecting to see at least some improvements in OS X. Let's have a quick look at Travis in case C-Dash is lying to us. And we'll just okay. So that actually doesn't look too bad, but clearly we could be having lots of errors here and it's just not telling us about the test errors. Let's have a look at the last lines of this log file. Okay, that's not too bad. We only have 4 failures. So I think we probably just had probably exceeded the maximum number of builds or something, because on C-Dash, because that actually looks good. I would expect to see okay, right, so there was some kind of issue here with the sorting. So yeah, that things are much more improved here. Now we have some warnings and some fails, but as you can see, we've now reduced quite dramatically the amount of warnings and failures, which is much better. Okay, we expect some failures because we know that there are some tests that are not passing on all platforms. But see, this is much better because now you have a much better sort of view of what's really happening. And even though we can't test everything in the relational model, at least we can test everything else. So it's no excuse just because something doesn't work that everything stops working, because then you can't see anything. Interestingly enough, Windows build on Dogen seems to have gotten a bit worse. Let's have a quick look at how we were doing yesterday. Well, actually not yesterday, but maybe 4 days ago. Clanksiel. Oh, okay, so we seem to have lost 10 failures. What I'll do as well, for good measure, is I think I'm gonna set these builds to be experimental, given that they're failing. Let's just have a quick look at how you do that. So if we have a look at what we're doing in reference implementation, at present all the builds that are failing are marked as experimental, and these are the Windows and OS X. So if I just jump over to C++ in the reference simple, and if I have a quick look at, say, C-test, I guess. No, probably Travis, I think. Keep pressing diode. One should not be opening too many files. So as you can see here, we have marked certain builds as experimental, and we can easily do the same thing for Dogen. So if I go to Travis, what we're saying at the moment is for Dogen, Clanksiel builds seem to be pretty known to fail. I wonder if it's both debug and release. So sorry, we have to go back again to the 4 days ago. it's only release. So ClankCL release seems to be a bit problematic. Of course, ClankCL is Appfair, not Travis. So let's just see if we can isolate release and debug. And of course, it's not as easy. ClankCL continues. Yes, unfortunately, we can't actually set just the debug because these are configurations here. So you know what? I'm going to leave them as production because the truth is we are shipping the binaries from ClankCL at present, even though we have those failures. So these are not experimental. We'll just leave them as it is. After much thinking about this is probably the right thing to do. Which means we are done for today, I think. Thanks for watching, and I'll catch you next time.